Area is the number of 1 by 1 squares that fit into a shape with no overlap or overhang. So first we're going to prove that the area of a triangle, the formula for that is base times height. And we're going to do this in a way where we can count. So we're going to divide it into the 1 by 1 squares because we know that's the area. And we're going to go for the base and the height. So the base is the bottom and the height is how high it goes. So we know that in this, then we will multiply the number of 1 by 1 squares and the height by the number of 1 by 1 squares along the base. This would be the more advanced way to do it. Otherwise, we can just count the number of squares that are inside of this. So in this example, it would be 1, 2, 3, 4 squares for the height, and 1, 2, 3, 4, 5 squares for the base. So the area of this example triangle would be 4 times 5 equals 20. And we can also get this by counting the number of squares that are inside.
When we talk about area, we talk about multiplying b times h. And the reason that we multiply instead of adding is because we don't want to sit and count each square, because this is the more efficient way to find the area. So we see that there are b columns, each with h number of 1 by 1 squares. So it's base times height because multiplying is when we have a certain number of the same sized groups. So that's why we have a certain number of 1 by 1 squares on the bottom and a certain number going on the height. So that's why we can do base times height, and it is more efficient than adding them all together.
So the 3 different triangles we're going to talk about today are the ones where the height is on the triangle, inside the triangle, and on the outside of the triangle. So the first one we're going to start with is when it is on the triangle. So for this one, the height is on the triangle. So to do this first, we're going to move this triangle onto the other side so that you can see it's a perfect rectangle. And since we can see that the base is on this triangle is the same that it would be on the whole rectangle, and the height is the same, we would know that we would do base times height to find the area of the rectangle. But we can see here also that the triangle is half of this new square, so that's why we would times it by 1/2. So the formula for this would be 1/2 base times height to find the area of this triangle. So this triangle, the height is in the inside. So when you have a triangle with height in the inside, you're going to take this side of the triangle and move it over here, and this side of the triangle and move it over here. So you can see by doing that it makes a full rectangle, which, as we remember, the formula of a rectangle is base times height. So we can also see that because we translated this side over here and this side over here, that this triangle is still 1/2 of what the whole rectangle is. So this also proves that this triangle formula can be found by also doing 1/2 base times height. So for our last triangle, the height is outside of the triangle, and so this one's a little more tricky. So this triangle, this part right here is the base, but the part is the whole, because you have to extend the height outside of the triangle, is big B. So in order to find what the little b base is, you'll subtract big B minus little b. So we know that the formula we're trying to get to is 1/2 base times height. So in order to prove that, we're going to subtract the 1/2 base times height minus 1/2 big B minus little b times height, because we don't want to find the area of this triangle right here, because that is just how we use to find the height. So in order to do this, we can distribute. So we know that it would cancel out the big 1/2 big base times height and then the 1/2 big base times height. So you would be left with 1/2 base times height, which then again finds the area of just this section because we distributed out all the rest.